binomial expansion on this. This is 1 plus n e n plus n into n minus 1 by 2 e n square and so on. Correct? And yeah, so can I write like this? N is greater than 1 plus n into n minus 1 by 2 en square. I'm taking these two terms, and you'll be surprised to see why I'm taking this and this only. I'm not taking ne here because here also it was n. So if I take ne, and n will get cancelled, or something will happen. I will not get any relation. So I need some n term after cancelling. That's why. So I'm taking 1 and na. So I'm writing n is greater than 1 plus n into n minus 1 by 2 en square. What else I can do? N minus 1. What do you know about n minus 1? That is greater than n into n minus 1 by 2 en square. Correct? I'm taking 1 that side. What can I do now? N minus 1 and minus 1 get cancelled. I'll be having this is cancelled. I'll be having en square को एक साइड रखते हैं, बाकी को अलग रखते हैं, तो I'll be having en square that is less than 2 by n. Do you agree? Just check. Yeah. When en square is less than 2 by n, what can you say about mod n? That is less than root of 2 by n. Yeah. From here also we are done actually. If you use triangle inequality or sandwich theorem, we are done actually. Let me write it. That means what? Minus root of 2 by n is less than en, and that is less than root of 2 by n. This guy goes to 0. This guy is also going to 0. So en will go to 0. That means what? You are having limit and tending to infinity. En goes to 0. But this was not we are supposed to find. We are supposed to find something else. We are supposed to find limit of this. Correct? So let us do limit n tending to infinity n raised to 1 by n, that is equal to limit n tending to infinity n raised to 1 by n. I am writing as 1 plus en. Now I know that limit an goes to 0. So this is 1 plus limit n tending to infinity en, and that is 1. Hence proved. Yeah. Go back to the proof and check whether it's correct or not. Yes? Is that okay? Main observation was n raised to 1 by n depend on n. This constant depends on n. Okay? Yeah. And there are some more you need to all the time you need to use this phi standard sequence to say about convergence of any sequences. If you get any sequence, then because अपने पास कोई भी अपना rule नहीं है, so you just need to relate with these people. First one, second one, third one, fourth, and the fifth one. Correct? Let us take some example. That means, what can you say about limit n tending to infinity 2 raised to n upon 3 raised to n? What can you say about this? Anyone? Yes? Can I relate with your standard sequences? Yes? Hello, can you hear me? Yes, yes. Think about it. Can you relate with your standard sequences, whatever we did, all five? Just compare with one of them. Perfect, very nice. And how will you do that? How will you write it? Just you need to write 2 by 3 raised to n, correct? And you already know that 2 by 3, this is between 0 to 1. So what is the answer? This is going to 0, correct? Nice. Nice. This was the trick. Good. Yeah, one more limit n tending to infinity 3 raised to n upon n factorial. Can you say something about this? Now, which one goes faster to infinity? My question is, which one goes faster to infinity? Whether 3 raised to n goes faster to infinity or n factorial goes faster. I just want to have a relation between 3 raised to n and n factorial. I just want to see which one goes faster to infinity. Try to see when you're putting n equal to 1, you're having this is 3 raised to n. Alright, 3 raised to n and factorial here. I want to see which one goes faster to infinity. When I put n equal to 1, this is having 3, this is giving me 1. When I put n equal to 2, then this is 9, this is 2 factorial, correct? What about next? Yeah, 2, correct. What about this? 27, na? And what about this? 6. What about this? 81. And here 24. So which one is going faster to infinity? Now think about it twice. Yeah, n factorial. Why that is so? How did you observe that? Try to see the first term here it is 3, second term is 9, third term is 27. Let us observe this. This is 9 threes are 27. That means in the third term it is taking 3 times and it is taking 2 times. It is again 3 times. 3 twos are 6. And what about here? 27 twos are or threes are? Threes are. Fours are I think. 4 threes are, no, threes are. It is approximately equal to 30, and suppose it is 30 and you want to go make to 20, so it is approximately 2 point something or 3. 3 will be higher, it will be something 2 point something. Do you see? And what about here? 6 multiply what will give you 20. 4 sir. Do you see this guy is going much faster to infinity? Do you observe the pattern? The condition was not to see the values. Condition was to try to relate with the previous one. How much they are going towards. In the first case, it was 1 and 1, so it is 2. Here 3. Here in the starting it was okay, but when the number is increasing, this n factorial will go faster to infinity. That means what? 3 raised to n will be lying behind somewhere and n factorial will be towards infinity. That means this will be something 1 upon n form. Just observation. I'm not proving it. I'm just telling you to observe. This will be something like this, or something say n upon n square form, something like this, where this n is going very slow and n square is going faster. Correct? I just want to relate this. 3 raised to n that is less than n factorial 3 raised to n minus 1 शायद या शायद n minus 1 आएगा something the relation I just want to write this, that is b raised to n, it is less than equal to n factorial. Or I'll just give you one relation whenever you are having like this. So yeah, so b raised to n is less than n factorial. And maybe I think in your induction we may have proved, you guys, I don't know whether you have proved something or not, but you could prove that by using induction. See, we are not talking about starting numbers, huh? Starting numbers may be different or same भी हुआ तभी भी चलेगा. We are talking about when n goes to infinity. We are talking about for larger n. We are not talking about that, the smaller one. Okay, or still if you're not agreeing to this, then let us see 3 raised to n upon n factorial. Let us see how this is forming. 3 raised to n, that means what? 3 into 3 into 3 into 3, how many times? N times, and divided by n factorial, that means what? 1 into 2 into 3 into up to n. When they are having smaller number 3 तक number है तो ठीक है, but what about when the number is going to be bigger, then this is going to be having an issue. Let us see. Suppose I am taking this as mm, let us form a pattern. Let us see what is 3 into 3 and 2 into 1. So this is 9 by 2. I am taking first two term of this, first two term of this. So it is 9 by 2 into 3 into 3 into it up to 3. This is n minus 1 times now. Earlier it was n times, and here it will be 3 into 4 into like that up to n. Okay, now 9 by 2 multiply by what is this? 3 by 3 multiply by 3 by 4 multiply by 3 by 5 and multiply by 3 by n. Why am I writing like this? You'll see. Note, 5 is greater than 4. So what is relation between 1 upon 5 and 1 upon 4? Less than, correct? Implies what? 3 by 5 is less than 3 by 4. Do you agree? 3 by 5 is less than 3 by 4. Similarly, 6 is greater than 4. That means what? 1 upon 6 is less than 1 upon 4. Implies 3 by 6 is less than 3 by 4. Do you see? Each of the term after 3 by 5, everybody is less than 3 by 4. 3 by 4, 3 by 4, everybody is less than 3 by 4. So 5 and 6 was not special to me. Next, what I will do? 7 is greater than 4, then again I will take the same thing and again multiply by 3. So what I can write, for all n greater than 4, what is my observation? 3 by n is less than 3 by 4. Do you agree? And I'm starting from 4, 5, 6 like that. Do you agree? Just relate with this. Can I write like this? That means my whole term is now changing into something like this. I'll just write. Uh, Let me just relate it. 0 is less than equal to en, but what is my en? 9 by 2 into 3 by 3 into 3 by 4, and after that everybody will be less than 3 by 4, but I'm writing here 3 by 5, 3 by 6 and so on. How many terms are there? That is, I think, n minus 2 something. And so can I write this is less than equal to 9 by 2, 3 by 3 is going multiply by 3 by 4, 3 by 4. Can I write like this? 3 by 4, all the time 3 by 4. As per the previous condition. That means what? You are having this as 0 is less than equal to en, and that is less than equal to 9 by 2 into 3 by 4 raised to n minus 2. Yes, this was n minus 2 times. So I don't require n minus 2. इसको मैं क्या करूँ? If I want to have only power n, so I can put it as 0 is less than en is less than equal to 9 by 2 into 3 by 4 raised to n, multiply with whom? 4 स्क्वायर बाई 3 स्क्वायर. डू यू सी? -2 को मैंने सेपरेट किया तो -2 था, तो इट विल जस्ट इंटरचेंज, न्यूमरेटर डिनोमिनेटर इंटरचेंज. करेक्ट. सो ये 3 स्क्वायर इज 9 is gone, and this is multiplied, so this is 0 is less than equal to en, that is less than equal to 16, मतलब 8 3 by 4 raised to n. What can you say now? Where does this guy go? This guy is tending to 0 because this is constant second. What can you say about this? 3 by 4. 3 by 4 is always lying between 0 to 1. Do you agree? Yeah, perfect. Tending to 0 by the standard sequence. So this will also go to 0. Do you see? So an goes to 0. This is what we wanted to prove. So from here also we proved, and from the observation also you should prove that you should see ki, which one is going to infinity faster. If the denominator is going towards infinity faster, then it will be something of 1 by n form. So this is going to 0. This is what you should understand. Later on you'll see it does not come automatically. It takes time. One more question. If you take en is equal to n square upon n factorial, what do you think? What do you think? Hello, can you hear me? Yeah. In the who is going faster to infinity? Whether it is n square or n factorial. Still, if you are having issue, तो put करने का देखने का. N square लिखा, n factorial लिखा. For 1 it is 1, for 2 it is 4 and it is 2, for 3 it is 9 and it is 6, and for 4 it is 16 and it is 4 factorial. What is 4 factorial? 24. Correct. And what about next? 25, and here 5 factorial is 120. Now 5 factorial is 120. So whenever I am taking limit, that means what? I don't want to see the starting term. I want to see the as large as I can see, as n going to infinity. What is your observation? Who is going to infinity faster? N factorial here also. That means what? N factorial is dominating. So this is of the form 1 upon something n. 1 upon नीचे n का term, ऐसा type. Then again this will go to 0. So n factorial is the on the top. Correct? So that was just a simple trick to say, but still you can prove it. You have to still see that n square को हम लोग क्या लिख सकते हैं? N into n, and in the denominator n factorial. So if you hello, can you hear me? Yeah. So suppose I don't want to go with this method, or I want to prove. So let us prove. So what is n square? I'll write in the numerator n factorial. That means what? 1 into 2 into 3 into up to n. Correct? What should I do now? Here, can I can I take in the denominator, can I take n common or n square? Let me take n square common. If I take n square common, I'm already having one n. Oh, I'll put some more terms so that it is quite clear to you. Into say n minus 2, n minus 1 into n. Okay, suppose I want to take n square divided by, I want to take n square here, so one n is already there with me, and can I take one n from here? If I take one n outside, then this will become 1 upon 1 minus n. I'll just write and check whether it is correct or not. 1 into 2 into n minus 2 I am keeping as it is. In the n minus 1 I am taking 1 minus 1 by n. Can I write like this? Just check. Yes, do you agree? So n square get cancelled. So n square get cancelled. Here you will be having up to n minus 2 multiplied by a. So to find the limit, that means what? Let me just write limit n tending to infinity en. I just need to find two limit n tending to infinity 1 upon 1 plus, oh sorry, uh, 1 into 2 into up to n minus 2 multiply by 1 upon 1 minus 1 by n. I need two limits n tending to infinity. Limit, I need two limit to find out. Correct? Okay. And do you know something about this? Where does limit goes to as n going to infinity? Do you see this guy is not a problem for me? Correct. So this is going to 1. So my question is now, this is becoming as this 1 upon 2 up to this one. Right. So I need a relation for this. So let us see. 1 into 2 into 3 into up to n minus 2. This is always greater than equal to n minus 2. Do you agree? So what about 1 upon अगर किया तो? What about 1 upon 1 into 2 into 3? Correct. N minus 2. That is less than equal to 1 upon n minus 2. Nice. But what I want something else ना. I want ये भी है साथ में 1 upon 1 minus n है. So I want that also. Yeah, अगर if you want to ignore this part, then that is also acceptable. Ignore किया, that is this is going to 1, so that is not a problem for me. And this is between 0 to 1. So again you can use triangle inequality, sandwich theorem. This guy goes to 0. This is 0. This is also going to 0. So what can you say in between? This will go to 0. Correct? Yeah. So what is the final answer? That is limit n square upon n factorial, that is equal to 0 when n goes to infinity. Yeah. One more part was remaining actually. Let me just quickly state that. Hmm. If I take en as 1 plus 1 by n raised to n, correct? Then this sequence is also convergent, and we don't know the limit. The limit is, we will just know that limit is lying between 2 and 3, and that limit where does this converge to, that is called E. You already know what is E, but we are not going to prove this converge to E. That proving that this converge to, because E is an irrational number, we cannot prove that with knowledge we are having till now. We cannot do, we need some extra concept for that. So we'll just prove the limit of this is lying between 2 and 3. Correct? So to prove this sequence is convergent, that is what we can do. We can prove that this sequence is convergent. And how can we do that? Do we have a theorem which can tell you that the sequence is convergent? We have so many theorems. If my sequence is monotonic increasing and bounded above, can I say something? If my sequence is monotonic increasing and bounded above, can I say something? Hello? Yeah, if my sequence is monotonic increasing and bounded above, then it is convergent. Correct? So we are going to do that only. We are not going to prove this is converged to a point. We will just prove that this is monotonic increasing and bounded above. That's it. We'll prove this is bounded, and the bound is En is always between 2 and 3. This is what we are going to prove. The first part, and second part will prove this is monotonic increasing. What do you mean by monotonic increasing? En plus 1 minus En, that is greater than 0. So maybe I'll give just some time for you to think about it. Can you prove this, that whether it is bounded, that is En is lying between 2 and 3, and En plus 1 minus En, that is positive, that is greater than equal to 0. If you can do that, then we are done. Then we can say that this sequence En is convergent, and the limit it is we are assigning, we are not proving that limit is that E, limit n tending to infinity 1 plus 1 by n raised to n, that is equal to E. So in the standard sequence we are having one more sequence now. Okay, I give this as a homework to you. Try that whether you can prove. Otherwise we will do it in the next lecture or further. I'm just telling you to try. Okay, and also you can prove this limit n tending to infinity 1 plus 1 factorial plus 1 upon 2 factorial plus 1 upon n factorial, that is also E. These are the two things. You just prove this, that this sequence En, that is lying between 2 and 3, and En plus 1 minus n is positive. That means what? It is increasing sequence. Monotonic increasing and bounded above. Here it is, we are having both the bound, lower bound and upper bound. If we can do that, then that's it. Okay, I just give this as a exercise to you. Okay? Yeah. Okay, yeah. I think now I should stop, as it is 5:56. Okay, thank you so much everyone. We'll see you in the next lecture tomorrow.